Next topic is kinetic energy. We have discussed that work done is the dot product of force and displacement, where force is the mass into acceleration. So we can write work equal to mass into acceleration dot s. And using the equation of motion, which is v square equal to u square plus 2as, this can be written in vector form as vector v dot vector v equal to vector u dot vector u plus 2 into vector a dot s. So we can find the value of a dot s as 2a dot s equal to v dot v minus u dot u. So a dot s is equal to v dot v by 2 minus u dot u by 2. Now substituting the value of a dot s in the equation of work, we will have m into v dot v by 2 minus u dot u by 2, or this can be written as 1 by 2 m v dot v minus 1 by 2 m u dot u. If we convert this dot product, we will have 1 by 2 m into v, this is the magnitude of vector v, into v into cos of angle between them, which is 0 degree, minus half m into u into cos 0 degree. Cos 0 is 1, so we can write it as half m v square minus half m u square. Here we introduce a new physical quantity which is known as kinetic energy. Kinetic energy of a body is k, which is half mv square if mass of the body is m and velocity of the body is v. Unit of the kinetic energy is same as of the work, it is joule. It is a scalar quantity and its dimensional formula is ml2 t minus 2. Kinetic energy of the object can be defined as the measure of the work that object can do by virtue of its motion. Using the expression for work, which we have found that W equal to half mv square minus half mu square, we are use the initial velocity of the object and v is the final velocity due to the work. Then it can be written as the kf, which is the final kinetic energy, minus ki, it is the initial kinetic energy, or work done is equal to the change in kinetic energy of the object. This is called the work energy theorem. To state the work energy theorem for a variable force, we use the physical quantity which we have introduced is kinetic energy given by half mv square. Differentiating with respect to time, we can write it as dk by dt equal to differential of half mv square. Because half and m and constant, so they can be taken out of the differential, so it is half m into differential of v square. It is equal to half m, and differential of v square is 2v into dv by dt, and this 2 and 2 get cancelled, and dv by dt is the acceleration, so we can write it is ma into v or f into v. This is the velocity. Velocity is the rate of change of displacement, so we can write it is f into dx by dt, and it is equal to dk by dt, or we can write dk equal to f into dx. Now integrating the expression, we will have integral dk with limit k initial to k final, and it is equal to integral f dx from position xi to xf. So it is k into limits are ki to kf equal to integral xi to xf f dx, and this term is the work done. So we can write kf minus ki equal to w. This is the work energy theorem for a variable force.